Jiru, co-founder and CEO of MoBagel. And very many thanks to Simon and Natalie for this space, and also volunteers Brian for organizing this event. And today I'm going to talk about predictive AI for IoT. So AI is a big word, IoT is a big word, and how is a startup tackling this problem in Silicon Valley, and also we have presence in Taiwan and Japan. So first, I'm gonna talk about like why predictive, why analytics for the IoT world. So first, you can see that if you're building any website or if you're building any mobile app, you always want to embed analytics to get to know how users are using your app. And these are what we call all the online data. Like when you register Gmail, Gmail has your data. When you register Facebook, whatever you act on Facebook, it's data. And the data we're seeing today right now, basically, it helps every software business to actually understand their customers, how their customers are engaging with their software, their app, their website, or whatsoever. So the online data analytics is very matured. And people expect online data because it's so easily collected, because it's at the internet, right? It's software. So basically, all you can see, like all the software companies, they always rely on the online data analytics to make their business decisions. Like, should we put a button here? Should we increase the views here? And whatsoever. So the problem we're talking right now is that you can see there are massive offline data, which we called any of the data that is actually like, I'm hitting this podium. Does anyone know, like, beyond this room? No, because this podium is not connected to the internet, but this is actually the data that we're seeing that will be online in the future through the IoT space. So you can see, actually these kind of physical data, they actually contribute to more than 95%. It's just a rough guess because it's just too big. So this will be changed because of IoT. And IoT is going to generate this immense data. It is projected to be more than 44 zettabytes of humongous data that anything will be collecting. Like in the future, this projector, that clock, or even like this table, this chair, someday they will be connected. Probably you don't think it's gonna happen today, but we already see many and many more things getting connected to the internet, and therefore generating a lot of data. So that's why MoBagel is doing the topic on the IoT analytics, and that's why we need the AI to do this. Because as we started collecting IoT data since the start of 2015 last year, we noticed some major problems that we're seeing in the IoT data space. For example, like the first problem is that usually there's not a ready scalable cloud to store all of your data and to analytics them all at once. Like even if you try simply Google Analytics, it takes a long time if you're streaming like gigabytes of sensor data each second. Like, can you imagine that? And also the second problem is that IoT data is way too messy today. For example, like any device can get easily offline. Like if you have a Nest in your home, drop cam, when they get offline, actually these data just disappear. They are just null value. Nobody has the missing data once the device gets disconnected. So because of the connectivity instability right now, and also sensors being constantly out of battery, that's exactly what we see for any sensor network that exists today. And these problems are already happening. So the third one is that it is very, very difficult to find the right algorithms, to find the right way to actually model and then predict what's going to happen to your IoT system or to your IoT device. So all these problems is kind of like what we see as like a new problem. Like whenever you install a sensor network, you want to know how users are interacting in this space, right? Or whenever you make your washing machine online, you sell your washing machine, you want to make sure that the user are always satisfied. You don't want to like see the machine broken the second day, but you don't know it, because that's the reason why you connected the washing machine in the first place, right? So these are all the problems that we're trying to solve. And how are we solving them? We're using AI technologies to actually enhance the prediction rate. So this is our solution. We have a really scalable, reliable data infrastructure. Later on, I will do our demo. And this is all weaved with our Decanter AI engine, which is responsible for predicting what's going to happen to your IoT devices, whether it's a sensor network, whether it's a connected home appliance, office appliance, or even it's like a vending machine on the street, or even it's like a post machine point of sale system. So these are all our customers right now, and we use this Decanter AI engine to help them to actually find the data pattern, and then we can start predicting like normally what should happen. But what about like if your device gets disconnected? We can actually predict when's the next time your sensor is gonna be out of battery, that's gonna be offline. So we call this an AI system because think about this, like if you have a machine learning model in place that's doing more work for you. So let's say the example of Gmail. So Gmail is constantly sensing whether an email is a spam or is it normal. So they have a machine learning model there. So traditionally, what do you do with that model? Usually, well, in Google for Gmail, they rebuild the model every single day when you're asleep, and then when you wake up, there's a new machine learning model. And it optimizes over their specific algorithms. So they already have the data science already in place with the algorithm and with the period of how they should rebuild itself, and then it's there. Unless something really bad happens, then their data scientists go back and check, okay, what's going on, let's solve this. But this is actually not suitable for the IoT space data that we see because it changes too fast. For example, like one of our clients, they was building their washing machine data, and we were helping them to build them on top of the weather data. But like at one time, suddenly their connectivity just lost. But how do we deal with that problem? How can a machine understand the infrastructure of the IoT is just not ready yet for this stable machine learning of predictive AI? Because our goal is to predict and model the IoT data, and we use the AI approach. And also, we optimize over more than 20 algorithms. So for example, like in machine learning, you can see clustering algorithms, or you can see regression. That's the easier ones, or you can see neural network, deep learning. There are so many algorithms, but traditionally, even like data scientists in Google, like Facebook, they choose their algorithm, they build their data pipeline, and then they just leave it like that. But in the IoT world, we found out that it doesn't work. So that's why our AI robot needs to use all these algorithms and to see which has the better accuracy, and then they will just simply replace the old algorithm. So this is how we work inside, and on the outside, basically, this is how we achieve some amazing accuracy based on our the data that we're running day to day. And we train our algorithms and we see, okay, how is our predictive AI going? And how is an A company or a G company compared to our accuracy rate? And we make sure that we're on top of it, because if we're not, our AI robot will simply grab that result. So that's how our AI make sure that it always gets our customer the best data model. So this is the decision-making process that we help our customers to build. So basically, for any kind of IoT data, which we call it offline data, for example, like just simply hitting this table, it will all be streamed to our MoBagel cloud. And we are a cloud infrastructure that holds all these data, and our predictive AI will start modeling your data. Once it's connected, and once you start streaming IoT data to us, we will start doing the data modeling, and we'll let you know like when it's ready that you can actually utilize the result. So for example, we will be able to do real-time prediction. For example, like if you have been streaming like sensor data, we'll let you know the pattern of this space, that of what parameters are you collecting and what's going to happen next week and even like next month. Of course, next month will be more inaccurate, but next week is usually like a range. And 2 weeks is the range that we see. It's pretty accurate. So you can start making your business decisions. For example, like you can enhance your firmware performance. So one case is that we have washing machine connected to our system, and then we will record every user interactions on it. So basically, you should learn that, hey, why aren't my users pressing this button? Something must happening, and you can make that button bigger. So that's what we call performance optimization, and also predictive maintenance, of course, and also business opportunities. And this is one case that we did with our customer. So it is a 30 billion yen business in Japan, and they are owning more than 10,000 washing machines throughout Japan in 1,000 stores, which is Laundromats. So it's what we call like self-service machines. It's kind of like a connected device, constantly generating money for you. So it's kind of like an external employee. That's why the company really want to like have a really good management of all your employees out there serving your customers. But their problem is that they've reached a certain growth and their growth stopped because they never knew like when or why would the customer come clean, dry, wash their clothes. And each demand actually has a different data modeling that they need to build in order to understand and to predict when is the next time the customer is going to come. So what we did with them is that, of course, they streamed every data transactions, every human interactions, and every machine and sensor data to MoBagel. And then we started fetching all kinds of open data. So this is our AI's job. Our predictive AI is responsible to fetch all kinds of data sources and to put them together in a metric that the AI can understand and start do the data modeling using all kinds of different algorithms. So what we found is that weather is, of course, is a really contributing factor to their customers' demands. So basically, based on that, we could build their revenue prediction model. And we started to do real-time prediction, and then we transformed that into campaigns. So basically, for each store throughout Japan, they have different weather, different demographics, formation. So based on that information, we'll be able to understand, okay, so demand's gonna drop in this laundromat, and then we can just push a real-time campaign to the local stores, to the individual machines, and have different pricing. So that is basically like a business opportunity for our customer. And so basically the concept is that we collect data that used to be offline, and we do the data modeling online, and then we feed back to the offline world to actually change the machine's behavior. So in this case, we can actually generate an 800 million revenue increase throughout the year over 1,000 stores. So it's because of this good result that we are currently continually to engage with them, and also we constantly push out campaigns and we see the result and we see whether we are predicting good or not. Yeah. So any questions before I just keep continuing? Yeah.
So is your product integrated after the appliance is manufactured, or is it the manufactured time?
Yeah, that's a very good question. So our customers come both ways. For this case, they already connected their washing machine, but they were storing the data. They were just not using it in any way. So basically, they poured out all of their historical data onto our cloud, and then we do the data modeling, and then the real-time prediction. So for any new data, they stream it to us directly. But for all the old data, they just imported all the data from their old database. Yep.
Is it supervised or unsupervised?
So this is kind of like supervised. Yeah, because it's kind of like a POC case, like a proof of concept. So they want to understand exactly each step what we are doing with their data. Yeah, but right now our predictive AI is also trying to do the same thing with the unsupervised to achieve like a good and even better result.
Do you push your updates out to these sensors to change their collection patterns, or do you have the ability to push back out instead of just stream one way?
Oh yes, so we actually push it back to to each individual washing machines to change the pricing, like dryer or washer or cleaner. Yeah, yeah. So this is kind of like the typical data flow, what we call. Yeah. So this is one case. So basically, for all kinds of self-service machines, we use like this methodology to help them actually understand and to model each purchase or each transaction's benefits throughout the time. And then they can actually predict like what's going to happen because of our data modeling. So basically, this is the, it's not very clear. Okay, but this is the dashboard here. So as a laundromat owner, I want to understand exactly what's happening, right? So if you can see like the right side, it's basically like how we say how accurate we are. So in this case, in this case, we achieved an R-squared value of 0.772, which is pretty good. So usually anything above like 0.7 is good as an R-squared value for a machine learning model, which means that it can pretty accurately predict your revenue stream. So in this case, we have the prediction on the right corner here, and then down there are the campaign's recommendations. And the left side is that they can choose like they want to build a new model. For example, they change many washers models. They want to build the newest one. Then they can specifically select the data they want to build the model with, and then they can run a new job. And then our AI will detect that. Our AI will start running, and then after that, our AI will keep improving the model. So this is the first case, and you guys are probably already pretty familiar with that. Yeah. Any questions?
Yeah, I got a question. Is it possible to define customized metrics based on your system, or how do your customers define what kind of problem they're concerned with?
Yeah. So I can show you like this example. So this example, it's kind of like a smart building site at Plug and Play. So Philips Lighting and Plug and Play, they installed a lot of sensors, and all these sensors have been constantly streaming data to our cloud. And in this case, basically, once our cloud started seeing data coming in, we will start generating prediction models, and then we'll start giving out metrics, saying like, hey, we can see. For example, in this case, it's about probably you can't see it really clear, but it's about like occupancy. If you can see, so it's actually the solid line is their actual occupancy, and the dotted line is how we do the prediction of the occupancy. So in this case, occupancy will be like their metric. So is there a question that how we define it, or?
Yes, sounds that you use AI to produce some sort of metrics.
So actually, I can do it in the demo later, but basically on our dashboard, once you set up your IoT data flow, you can actually choose your target.
Mm-hmm.
Yeah. So in this case, it's occupancy, but you can actually define like, I want to do data modeling on occupancy. And then you have to say like, what does occupancy mean? For example, there are like 100 sensors. And occupancy would mean that in any given time, how many sensors are on, divided by all sensors. So that's kind of like, you need to give us your prediction target so that we know, okay, so that's your target. And then our AI will start learning, yeah. So basically it's self-defined. You can say our customer use our dashboard to define their modeling target. So this case is like the smart building case where we actually predict like what is the office patterns in each room inside Plug and Play, so that we can actually recommend like energy saving plans as well as event. For example, like we'll recommend you like, hey, probably Wednesday is the best time to host this event because there will be most people in this space. And then more importantly, as an IoT network owner, you want to understand when is the sensors down or when is your system not working. Because if your system's not working, any data getting from it means false. So basically, because we can predict the pattern, once it's off the pattern, we will send our customer an alert. So you can say that our predictive AI is actually responsible for normal prediction and also false predictions, anomaly predictions. Because we can have this predictive model, that's why we can exactly let you know, like predictive alerts, like, hey, your sensors are out of battery and you really need to change it right now. Because if you don't do that, usually as an IoT network owner, probably you have 1,000 sites. How can you always stay on top of that? So that's kind of like the benefit. And I can show you later on in the demo that their sensors actually went out of battery yesterday. So that's exactly like the problem that like appeared and how we solved it. Yeah. So this is the smart building case. And we also have like energy systems case. So in this case, we collaborate with Panasonic in Taiwan. So basically they have many like solar panels on top of their kind of like their new smart homes for their customers. And they want to actually monitor in real time how people are using the solar panel versus using the regular energy. And with this energy patterns, they want to optimize electricity bills for their customers. So in this case, it's pretty simple. It's basically just like predicting energy usage, and you can find the patterns. Yeah. And the end goal is that they can actually recommend electricity plans for their customers. Yeah. And also they want to monitor their solar panels, make sure it's working and all that. Yeah. And this is a case we're collaborating with Advantech, and they have more than 5. They are so Advantech is world's top 2 industrial PC manufacturer. So industrial PC, so they manufacture point of sale system as well, because it's basically industrial PC, and they have their system in a chain store, coffee chain store in China. So for every of their POS system, they stream us all the purchase data. We can actually model with, like, so for each product, we will build a model for it to predict what will be the demand look like for next week. And so that's how they can make their stock decisions, as well as they can make their real-time customer campaigns. So in this case, they actually have a camera looking at the customer, so they know exactly the sexuality, the age of the customer, and what the customer is wearing, or like what kind of color this customer is wearing. So basically, it can involve in much higher, much deeper machine learning of actually clustering the customers with the product that they're purchasing. So in this case, it's a bit more complicated, but we're still using our machine learning AI to solve this problem. And so for any customer that comes into their store, we have a panel that's displaying to the customer, suggesting like, hey, probably it's time you get an iced coffee to boost their sales. Yeah. So this case is basically like this. Yeah. Any questions?
Is that illegal?
Well, because actually in Japan, when you stand in front of a vending machine, it already collects your sexuality, how tall are you, your age, and then they recommend your drinks. So it's just on the street, even. So yeah, it's becoming a crazy world.
So you build in the data from the video, or?
So they already have the system,
Okay.
and they're already doing their computer vision system.
Oh.
So they only give us the end result of the customer,
Got it.
like it's a girl, and how old, and what color, kind of like that.
Cool.
And the post also give all the sales data, right, online, right? So this is, everything is on the internet and give it to
Yeah.
your system.
Yeah. So basically, you match the data, and you do the clustering, and then you can do the prediction. Yeah.
Cool.
Okay. So this is kind of like our, as a startup, what are we doing, and in the customer space. For example, like we have customers. So SoftBank is one of our channels in Japan. So that's how we get a lot of Japanese customers through SoftBank network. And Advantech Yanhua is our primary channel in Taiwan. So they have many industrial PC customers. And in the US, we have Philips Lighting, and also we have Scarlett Tech, and many mesh network that's using our solution. Yeah. So basically, we're still a young startup, and we're still building up our cases. Yeah. So if you're interested, we can partner. And this is our team, if you're interested. So our CEO Adams, he was in Chunghwa Telecom. So he built the first big data platform in Chunghwa Telecom, similar to AWS, serving clients such as like Google and Yahoo when they first entered Taiwan. So that's how we got the data platform, the architecture from. And also he grew up in a hardware manufacturing family, so this is exactly like his family's problems. So that's how we started MoBagel. And I'm Yuri. I graduated from Stanford Electrical Engineering and D School, and I also took data science. And I worked at NVIDIA architecture before I joined MoBagel. So right now I'm at MoBagel as a COO. And we also have our advisory team, such as like Robert, Tong Yu, and etc. Like computer.
Can you talk about a little bit about your IP or patent situation? You say you have some kind of a patented like algorithm engine or something like that, or software?
Yeah. So basically, it's patent pending. We don't have it's not registered yet, but basically we have filed. The patent pending are around our database architecture. Yeah, of how we actually fetch and do machine learning and then give out the result inside our cloud database.
So we also have a demo section.
Yeah.
Right? So because we are engineering group, so I first see if you want to begin. So first time meet Yiru is in present staff present type of opportunity, and found out that they are young staff, and surprised they got good attention by VC, and also got the deal with a big company and want to learn a little more. But as an engineer, I really want to see how the system works and what's the real case they solve, right? So we asking Iru can show us cases, and also she can show us how the software look like and how you connect that and how it work. And
Yeah.
maybe we can use that in the future, or
Sure. Yeah. So I will finish the Philips lighting sensor network case, and then I can start from the beginning of how to start our service. If you're interested. If you're interested. Yeah. Okay. So this case is kind of like the backend dashboard for all the Philips lighting sensors. So if you can look at the device management part. So these are all their sensors that has been generating motion data. And they have this many sensors, but some of them are not active. And if you can go to so there are like 4 main sections. The first one is analytics, monitoring. So we have like real-time monitoring. And that's basically like the data we're seeing right now is moving slowly. And inside prediction, you can say like, okay, what is my target? So get back to Ofa's question. So basically you tune your prediction target here to let our AI know what are you trying to predict, because or else we will still give you default predictions, like basically each sensor predictions, but that's probably not what you want. For example, if you want to predict revenue, probably you don't have a data field that's directly called revenue, right? So you want to tell us what is revenue made of so that we can predict. And here is kind of like the recommendation part that you can see, like the dotted line is how we predict. So basically this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So you don't have much occupancy here. And today's Thursday. So actually yesterday there was like a breakdown. And so that's why we kind of like let them know that, hey, you probably need to change your sensors. Well, it's not here, I don't know when. But I think they changed their sensors today. You can actually see like the actual customer-facing dashboard that they're using. Yeah, so this is kind of like the current situation at Plug and Play right now at this moment. And these should be startups. And this should be the office area, so people already left, kind of like a Plug and Play staff area. And this is the startup area. So this is actually like the customer-facing interface that they're giving out to Plug and Play as like a property owner. But they use this dashboard to actually monitor their IoT entire network. So it's kind of like different layers. Yeah. Yeah. Just raise your hand if you want to like discuss anything. So any questions here? So basically what MoBagel does is that we will model your data and then we will tell you what should be the normal case next, but what should be the abnormal case that's going to happen, because we already have your normal data modeling. That's why we can tell when there is an anomaly.
Do you have more story on yesterday's data?
Sorry?
Yesterday's data.
You want to?
You see the gap over there, right?
Yeah, so that's exactly when their sensors went out of battery.
Just that simple like that.
Yeah. Yeah, because
It's like all sensors out of the battery.
because they changed their batteries like on a cycle. So they change it all at once. And then suddenly many of the sensors are like suddenly off.
But why you don't detect this in the early time frame?
Oh, we
This is the
detected
first
it.
time. Oh, you detected it.
Yeah, we detected it. So we sent him
Because I
like,
see your dotted line still looks like normal, right?
oh yeah, because, oh, so you mean in this case, like,
Right.
why didn't we know it's gonna happen?
That's right.
Yeah, so in this case, we didn't know. we didn't see it happening.
Probably first of the cycle.
Yeah, so
Then
I'm not sure, but I don't think it's first of the cycle, but I just think that, yeah, just not enough
cycle.
data, yeah.
But if you look at the motions, see, like a lot of motions even on weekends in the past, so I don't know, kind of interesting.
Yeah, because for the battery still lasts pretty long, I think around 2 to 3 months. So the pattern is still not good yet. The pattern is not good for machine learning yet because it only happened like twice or
How long have you monitored
this
particular
system.
plug and play? Yeah,
Almost a year.
it's a year.
Yeah, you should have experience like that.
Yeah, but
It's
then
hard to say, but battery may last
it's only
6
like
months.
yeah.
The
So
battery lasts
so
6
because-
months, then we don't know.
probably like after 5 years, we'll learn if the battery is constantly within 6 months. Probably that's possible.
But
So probably after 2 years.
And maybe still need extra information
Yeah,
like
it's
when
not-
they change the battery. Right? So this is something that's if not get into the system and is important, then maybe you know,
and
cannot.
then
Yeah.
5 years as a new battery, it lasts much longer.
And then and then it doesn't work. Yeah.
It's better.
Yeah, but that's a very good question. Probably I should ask our engineering team. Something's wrong here.
Yeah, and also, if you look at the motion sensor, so motion sensor is separate from the light sensor because the motion seems to be detected all right, right?
That's right. They are different
So
sensors.
two different
Right.
sensors, right? Yeah, that's what I'm
So
saying.
actually, the occupancy is already like calculated. It's not from
Not real.
the raw data.
Right,
yeah.
okay,
But
it's
this is raw data.
Okay, yeah, this
So-
is real motion. Okay.
Yeah. Yep. So
Have you considered like, when I look at your cases, they are not so much of the involved in terms of the stochastic process, because there are a lot of regularity in terms of the cases that is being presented. For example, for this case, occupancy, because human does have a kind
pattern.
of like a behavior in a way that Monday up to Friday, I kind of know the occupancy, even without any predicting model, I kind of know what's going to happen because most of the people will be out during the daytime and night, probably will be back. Same for your the robot cleaner or even your washing machine. So have you considered like things that, as far as the limitation of the model? For example, if you have more variable, in terms of the cases that you are trying to monitor or predicting, like stock market, for just an example.
Yeah.
I don't think you are up
Totally.
to that stage yet, but I'm just saying, have you like tried to think about when there's a random process involved, which is a lot more unpredictable as the cases that you represented, like the limitation of the model right now. What do you have like, what kind of difficulty that you think you might encounter in terms of the?
Oh, you mean, for example, like if we use this to the stock market, what's gonna happen? Like
Yeah.
there's more unpredictables.
Yeah. Because there are a lot more factors that
Yeah.
there's no way you could tell.
Yeah, I mean, if I can predict the stock,
Yeah,
how good would that be?
that is a difficult problem. I'm just saying that, from your models, the point of your experience that, or the experience that you guys have, what's the limitation that, you work on or things like that?
Yeah. So probably I can use the washing machine as an example. Yeah, so for our washing machine case, a lot of times our customers also challenge us, like, hey, that's common sense. Why are you telling me common sense? Like, if the weather, for example, like what we tell them is like, hey, okay, machine learning learned that if the temperature goes up, your washing demand will go up as well. So they will be like, hey, I already knew that. Why did you just tell me my common sense? So what we do is that we actually change them into numbers. For example, like when the temperature goes up 1 degree, and your cells will go up like 1.5%. And when you put that into number, they will understand like why they need machine learning, because they know exactly the factors gonna contribute. But as you said, like for example, like because this is still like human behavior, so there should be some rules in it. So if you say like the limitations, we would say it's basically depends on our AI. Like if our AI can find a good algorithm and can find the right data on the internet. For example, like we fetch for like open data and demographics, traffic, but of course there are more data that we're not, we don't have a hand on. And I think it's basically based on how sufficient can our system actually grasp the whole full picture. For example, like for the stock market, probably if you have an AI engine that can grasp all the data that's needed, probably you can still predict. So for our case, it's basically like reaching a good accuracy, then our AI would stop. Yeah.
Maybe I'll just put it this way. If let's say right now you have n number of variables and your variables scale linearly, what will be the processing time of your AI system?
So for the washing machine case, it was around 100 variables, and it was around 50 million data points. And
Per day or the
it's
whole
spread out.
thing? Okay.
It's spread out in 3 years. Yeah. And it was 100 variables, 50 million data points spread out in 3 years. And we processed it around, so for one job, we processed it around like 3 hours. Yeah. If you see. And
100
then,
variable per machine?
sorry?
100 variables per machine?
So basically, we put together all kinds of variables, including the sensor data on the machine itself, and also open data, like temperature, and what is the average household income in this area. Like all these becomes variables.
So is there any limitation about how much data or variable they can handle, and also the amount of data?
The time just gets longer, yeah,
Right.
to process the job.
Or becomes inefficient or?
Yeah, or it becomes inefficient. So we still try to achieve like a good result, and then because machine learning is all about having a good grasp of the accuracy, then you're done. It's not about being perfect. Yeah.
All right, so now let's talk about business. So if we have a real case application that we want to talk to you, and how we're going to get it started. You have somebody here in U.S., Silicon Valley, or?
Yes. We have a team here. We have a team in Taiwan. We have a team in Japan.
So we're going to talk to them, and then they will give us a quotation or something?
Yeah. So usually we can start with like a proof of concept, which you can give us the data that you're comfortable with, because not everyone are comfortable with giving out entire data at once. But if you can give us like a certain scope of data, and then we can do the POC. We will give you the model, and we'll see like, hey, how accurate can we get, and then we'll discuss with you, is this good enough, and then we can proceed. Yeah. But it usually starts with a POC, or I can demo like so we also have a developer plan. It's free to use if you want to use the developer plan. So let me log into another. So you can also start sending data through our API and not talking to anyone. Like you can just set it up, as engineers do. So I can log into the account I set up today.
And all the operation will be happening in Taiwan, not here.
Operation?
Operation in terms of data, video crunching.
Oh yeah, in the cloud. So we
I'm
have
talking about your server part of it, the physical part of it.
so we have AWS in the US.
Oh, right here.
Yeah.
So-
And
okay,
also
so
Japan.
The data doesn't have to go through the cross the borders.
No.
Okay.
So we have an API doc here, and for example, like whatever if you want to stream data from your device directly or from your server, we have different API docs, and also you can see like in different languages. For example, like if your backend is in PHP, then you can use our PHP package. You can just download the SDK, and then you can start streaming as data. Or you can import data, CSV file. Yeah. So there are different ways to do it. And currently in this setup, there's only 2 devices, but I can demonstrate if you guys are interested. I can demonstrate how to set it up if you like. So for example, like this is a project I created, motion sensor. We can create a new product. For example, like you want to call it like a new like washing machine product line, or just washing machine. So this is a new product that you set it up, and this is the product setting. So basically, this is your product key, and currently under device management you have no devices. So we have the API ready. For example, like we have 2 main API. One is register, which means that you, as for example, like you're a washing machine yourself, and your customer turned you on, and then you want to register, like, hey, I'm a device here, like, hear me out. So basically, you register with the register API with the product key, and then you can get a registered device. So I can show you here. I'm just using like Postman. So for example, like you can just register here. You can, once you create a new product, you go to configuration, product setting, and then now you have the product key. So you just put your product key here, and you just press send, and then here you created a device, and it is kind of like telling you like what's happening. And under device management, under device management, you can see that 8:30, I just created a new device. And currently there's nothing happening with this device. But now you have the device key. So basically, inside your device, as a washing machine, you already registered. So you're gonna get a device key. So you can use this key to do your job, like to do all the reporting, all the data points, sending. But in this case, basically, we're just gonna use the report API, which we will start sending report through this device key. So, so currently it's all like not. So this is the lowest level. Like there's no encryption because some of our customers they want to test it, so they don't want like huge encryption. And as you said, like many IoT device, they aim for like low power, not aim for security. So sometimes we get a request that, hey, I just want to use the simplest one. I don't need security. So this is the non-security version. But if you need security, we have like security encrypted. So in this case, you can say like, okay, the state is testing with the device key ready, and then you can just send, and it's good. So you can just refresh here. So you're already seeing like reports coming in today, and it knows that probably I'm here, San Francisco area, California, and you can see that, okay, this device has been active. So basically, at any given time, you can see exactly what's happening, what's going on through all of your devices. And you can see what did any device just said. So for example, in this case, it's a washing machine. So under the product setting, actually there's a default default parameter that you can send through a report, which is state. But of course, like every IoT device is different, right? The information you want to send from every device may be different. So actually you can customize the parameters you want to send to us. For example, like if you're a washing machine, probably you want to send the temperature, or let's just say humidity, or like water level. So you have a water level that you want to keep every washing machine report their water level, make sure it's not flooding. And then you can say like it's a numeric type, so you just save it. So now under your device, you can, inside your washer, you can now say like, you can now simply put it into a simple JSON form. For example, like it equals to 50% probably. Then you can just send, oh, it's bad request. Did I spell it wrong? Oh. Oh, probably it's different. Device key. Okay. Oh, this is probably another device. Okay, so now it's sent correctly. And then under here, if you look at the real-time monitoring, you will see that, oh, okay, the water level, the first water level is 50 here. And if you send another time, like 25, and now you know that, okay, someone's sending 50, someone's sending 25, the average is this. So basically you can do real-time monitoring if you want to simply look at your machines at any given time. So let's just say, like, you can set it 15, or like 2. Yeah, so you'll see like what's happening to all of your IoT devices. And usually in this case, it's usually about smart meters. So our customers that has been doing like critical pipeline, that they want to like real-time monitor the pressure of the critical pipeline, water pipeline, oil pipeline. Usually they just use this. This is the only function that they use from MoBagel. Like they just want to monitor like everything's alright, so that they can like do any emergency. So like there is a notification place. For example, like if you want to say my water level can only be between 0 to 80, for example. So save it. So then, so now if your water level, for example, becomes like 90, you send it from the device, then you'll see like there's a notification telling you that, hey, probably it's not normal range because you already set your parameters. Yeah. And then, of course, there is the prediction part here. But as you can see right now, it's only like few data points, so it's not very precise. But you can see it like it starts predicting, but it will tell you that your data points are not enough. Yeah. So that's basically the point. And if you accumulate enough data points, they will have a better result, and you will see your data patterns. Yeah. So basically, this is like what our AI engine is working for. As it sees data, it will start generating data models. and it will tell you, hey, probably I need some more data. Can you tell me more? Or what is your target? Probably you need to change your target or whatever. Yep.
Can you pick your prediction algorithm? Because maybe they already have an idea.
Yeah, that's a very good point. So right now our dashboard doesn't offer this, but you can talk to us. Yeah, so we'll say like, okay, we'll run like this set of job queues for you. But because usually our dashboard users, they don't understand machine learning. So that's the point, yeah. But if you do, like it's great, then we can achieve a better accuracy with your input, yeah.
Okay. I think now it's a little late, but we still will open this room if you have a particular question that I believe our speaker would love to discuss a detail with you. But I think that today's takeaway, AI is not so far from us. Even I don't know how it's work, but there are tools available. And if I have data, I have a problem I need to solve. There are company can help that. They have a software ready, and it seems easier than than you thought, right? So it's
Yep, great.
Here we very appreciate your time, to share what your company is doing and share the real case. And she's just come back from Asia, right? So the company is booming. It's a lot of activity preparing the present for us. That's a thank for her time and the presentation.
Thank you guys. Thank you.